Hey everyone, I'm Nick from Coffee Before Arch, and in this episode of the Systems Programming Series, we're going to talk about file creation. So we mentioned file creation, we were talking about the open syscall last time, and we'll go ahead and we'll open that up for just a second to clarify some things. So like we said, we can use open to create files, not just open them. And we said that the third argument to the open function, or to the open syscall, we didn't use it here because we were just opening a file that already existed, which was this test.txt, but the third one was going to be access permissions. So what access permissions should this file have when we're creating it? And then we also had, just as a reminder, the second argument is this access mode and behavior. So here we're saying open it in write-only mode, and down here we're ORing these two bit flags together to say open it in write-only mode and also truncate the file when you open it, which means just dump the contents. So it turns out that when we're creating files, there's a set of these kind of flags that are very common to use, and because of that, they have their own function, which is the create function. So we'll go ahead and look at file creation.c. So here, we'll include some headers, so the same one we used last time, as well as this new one, the sys/stat.h. We'll use that for all the bit flags for mode that are defined, and so these will be basically for our access permissions. And then we'll also include assert just for some error checking. So we'll have a file descriptor. So just like open, our create function will also return a file descriptor for when it creates a new file. And it's important to know that we're talking about the different modes. We're talking about which users have permissions to this file. And we're talking about the owner, the group, and then everybody else. So different levels. And then each different level has 3 bits that correspond to read, write, and execute permissions. So can someone everyone that's in the same group, so users can be grouped together. So can they read the file? Can they write the file? And if it's not executable, can they execute the file? So in this case, what we'll go ahead and look at is a simple scenario where if we want to set, there's a special type, this mode T, and we'll call this variable mode, and what we'll do is we'll just OR all these flags together, or at least the flags we want to use. So in this case, we have this for setting for the user permission. We want to set the write flag, so we use this s_iwuser, and then likewise there's one for R, which stands for allowing the user to read the file, and then X for execute the file. And likewise there's the same flags for GRP, which stands for group, and OTH, which stands for other. Now, if we don't want to have to remember all of these different flags, or worry about writing a big long line of things that are ORed together, well, we can also specify this in octal. So octal is just collections of 3 bits, so it's base 8 instead of decimal, which is base 10, or binary, which is base 2. So if we were to look at this in binary, each of these 3 groupings of bits corresponds to a single number between 0 and 7. So here, this would correspond into, up at the very top, we have 7, so it'd be 4 plus 2 plus 1, which is 7. The second set would be 4 plus 0 plus 0, which will just be 4, and likewise for the last one, just 4. So we can also just specify this in octal if we're clever and we remember which bits correspond to what. So in this case, the first bit will be for read permissions, the second for write permissions, and the third for execute permissions. So when we say 0, 7, 0 just makes it so that it's interpreted as an octal number. So when we say 744 as an octal number, what we're saying is give the user read, write, and execute permissions, but give the other 2 groups, being group and then everyone else, give them only read permissions. So as far as a file name, we're not passing in one as far as we're specifying. Maybe we're just reading in a file or passing in from the command line. We'll go ahead and just create it in the file itself, which we'll call create_test. So you may be wondering why create is spelled without an E. Well, maybe you dislike this spelling, and well, the person that came up with it dislikes it as well. So he said it's one of his biggest regrets is not including an E in create. So like I said, there's a combination of flags that's very common when we're doing file creation, and that's specifying a file as being a write-only file, creating it, or with this create flag, this says create a file if it doesn't already exist. So instead of just failing if you're trying to open a file, if it doesn't exist, it'll go ahead and create the file as a new file. And then otherwise, if it does exist, or if it doesn't exist, it'll go ahead and just truncate the file. So it just empties the content so it's blank. So this is very common, so that's what this create function does. This create function makes it so we don't have to OR these 3 flags together. So all we need to pass it is a name, which is a path to wherever we want to create this file, and then a mode. So the mode being the permissions. So here, like I said, we're doing read, write, execute for the user and read only for every other for the other two groups. So group and then everyone else. So if just like open, it returns a file descriptor. If the file descriptor is -1, that means something bad happened. And so we'll go ahead and just print, file creation failed, and then we'll assert 0. So assert will just take it will just take basically a Boolean value, 0 or 1, true or false. If it's true, nothing happens. If it's false, it'll go ahead and kill the program. So if we get a -1, we'll kill the program. Otherwise, we'll print created file, we'll print out the name, and we'll print out the file descriptor. So if you remember from open.c that we looked at last time, there's 3 standard file descriptors, which are standard in, standard out, and standard error. So what we should see is that, inside of that file table, we're going to be adding entries when we create files. So we're going to open a new file for this for that process. And so what we'll end up seeing is a new file descriptor for that new file at 3, right? Because the first 3 are taken at 0, 1, and 2. So we'll go ahead and compile this code. So we'll do gcc-o file creation, and then we'll pass in the file. So there's our executable. So we'll go ahead and do /file creation. Okay, it says it created file create test with file descriptor 3. And if we look at our directory, we see we've got this new create test, and you see that it's also highlighted green, just like the executable. Well, that's probably because we set it as being having executable permissions. And we can also just check this by doing ls-l. We can find the permissions for a file. So if we do ls-l on create test.txt, so what we see, we'll go ahead and kind of zoom in. What we see is that for create test.txt, it has read, write, and execute permissions right here. And then this corresponds to the user over here, read only for the group, and then read only for everyone else. So that's that 7, 4, 4. So just like we were talking about these bit flags in Octal, they correspond to this. So we can check this, just from the command line. Okay, so that's the very basics of file creation using the create function, which, like I said, is really just a simplification of using open, so we don't have to remember or type in all of those bit flags every time we want to use them. So that's going to go ahead and do it for this episode. Feel free to check out all this code on github.com/coffeebeforearch. We've got all my other series on here as well, such as the GPU programming one, stuff on C++, and practical parallelism in C++. So if we go to the repositories, what did we look at today? We looked at systems programming. And if you go to file.io, it looks like I haven't committed it yet. So we can go ahead and commit that right now. So we'll remove create test.txt, and we'll move the binary file creation. And so we'll go ahead and do git add dot commit -m add file creation example. All right, and then we'll go ahead and push it to the Coffee Before Arch GitHub. All right, so now it'll show up, and here we go. We've got file creation.c in here. So feel free to download this and play around with it, and let me know if you have any questions. As far as the remainder of this series go, we've got a number of topics we'll be covering that'll be done here. So things like file I/O and advanced I/O, process management, including things like memory management as well. So that'll do it for this time. Of course, I'm Nick from Coffee Before Arch, and I hope you have a nice day.